Water exploded out of storm drains. Cars floated down city streets. Bridges collapsed. This wasn't an engineering failure. On a peaceful afternoon in June 2012, Duluth, Minnesota received 7 inches of rain. The damage reached $100 million. That wasn't an unusual storm. It was a storm that engineers had already calculated would happen, just not on that Tuesday in June. Every time it rains, millions of gallons of water disappear almost instantly beneath your feet. Not into the sewer. Into an entirely separate underground river that most people have never thought about. And when that hidden river reaches its limit, your neighborhood can become flooded in minutes. Most people assume all underground pipes connect to sewage treatment. They don't. Beneath every street runs a second network, completely separate, engineered independently, with its own carefully calculated limits. Understanding those limits explains everything about why some storms flood cities and others don't. Where does rain actually go? Watch it fall on asphalt. See it disappear into a grate. Most people never think about it again. But that water doesn't vanish. It travels through one of the largest infrastructure systems any city has ever built. For over a century, cities made a critical mistake. They mixed rainwater and sewage in the same pipes. The result was catastrophic. Disease spread. Cholera epidemics killed tens of thousands. In the 19th century, engineers like Joseph Bazalgette transformed urban sanitation with massive sewer systems. Over time, many cities increasingly separated stormwater from sewage, reducing disease and making drainage more effective. That decision became the foundation of modern urban infrastructure. It saved millions of lives. But it created a new engineering problem: 2 massive invisible systems running beneath cities, each with its own capacity limits. Here's how the storm drain network actually works. Rain hits the street. It flows toward the curb. It enters a catch basin, a grate designed to capture it. Underground, the water enters a pipe. In major cities, these pipes are enormous. Some are 10 feet in diameter, the size of a highway tunnel. The water travels through miles of interconnected pipes. Sometimes it enters a culvert, a massive channel built to move enormous volumes of water rapidly. Sometimes it flows into a retention pond, a temporary holding tank that releases water slowly. Eventually it reaches an outfall, the point where the hidden river connects to a real river, lake, or ocean. Most cities contain hundreds, even thousands of miles of storm drainage pipe. The Chicago Deep Tunnel project is 109 miles long and holds 2.2 billion gallons of water. Some underground stormwater tunnels are large enough to drive a truck through. The entire system is invisible to the people living above it. Yet it's one of the largest and most expensive infrastructure systems beneath any modern city. Here's what almost nobody knows. Every storm drainage system is designed for one specific storm, not every storm. That's the entire rule. Everything else flows from this single principle. Engineers didn't design these systems to handle every rainfall imaginable. If they had, the cost would be astronomical. Instead, they made a calculation based on 3 factors: acceptable flood risk, safety requirements, and budget. They designed for what's called a design storm. A 100-year storm doesn't mean it happens once every 100 years. It means there's approximately a 1% statistical probability of that level of rainfall occurring in any given year. So a 100-year storm could happen twice in a decade. or not happen for 200 years. A 10-year storm has about a 10% chance in any given year. A 25-year storm has about a 4% chance. Cities choose their design storm based on what they're willing to protect. A hospital or fire station might be designed for a 100-year storm. Protection is critical. A parking lot might be designed for a 10-year storm. Occasional flooding is acceptable. Most residential neighborhoods are designed for 10-year or 25-year storms. Engineers knowingly accept that some storms will exceed design capacity. This isn't a flaw. It's a deliberate trade-off. Building pipes large enough for the worst conceivable storm would cost dramatically more. So cities make a rational calculation, accept occasional flooding to keep infrastructure costs manageable. In June 2012, Duluth's storm drain system was designed for one specific capacity. Then 7 inches of rain fell. The system did exactly what it was designed to do. It filled completely. It reached its limit. Water had nowhere to go. It backed up through the pipes, pushed through the grates, and flooded the streets. Multiple factors make flooding more likely in modern cities than when these systems were originally built. Many storm drains were designed using rainfall data from 50 or 100 years ago. Development patterns have changed. More pavement means more water running off streets. In many cities, heavier downpours and growing populations are pushing systems closer to their design limits. Aging pipes leak or clog, reducing capacity. In Duluth, some of the oldest pipes were installed in 1880. They're over 140 years old and at the end of their design lifespan. Maintenance budgets fall behind need. The city estimates $4 million in annual maintenance needed but operates on far less. Climate patterns have shifted in some regions, bringing different rainfall intensities than when the systems were designed. None of this surprises engineers. They know exactly what's happening. The systems are performing as designed. The world around them has simply changed. Cities worldwide are adapting to these limits. Some are building larger culverts to increase capacity. Others are installing retention basins, enormous underground tanks that hold water during storms and release it slowly afterward. Some cities replace concrete with permeable pavement that lets water soak into the ground naturally. Others build green infrastructure, rain gardens and constructed wetlands that filter and absorb water. The most ambitious projects involve underground storage tunnels, massive chambers carved beneath cities that act as temporary reservoirs. New York City's Staten Island Tunnel holds 2.2 billion gallons. These solutions require significant investment and time. But they acknowledge something fundamental. The world has changed since these systems were designed. Modern infrastructure must adapt to modern conditions. Every city hides an invisible river. The question isn't whether it's still flowing. It's whether the future is beginning to outgrow the world it was built for. That's the reason it works. Subscribe for weekly explainers on the hidden systems that run modern life.